All right, let's take a look at the numbers to see how we did here. In this case, our input, we're interested in how much we put in and how much we got out. So we're going to look at efficiency. When we look at the in, we had about 2.2 volts, maybe sometimes a little less, and then 1.1 amperes, sometimes a little less. So this is a little variable over here, so we could mess with the numbers a little bit. And on the out, we had 0.63 volts and 0.1 amps. Again, those are a little variable too, depending on how the motor was whining and how efficient the little connection was. So in order to figure this out, we have to know how much energy each one of these electrons has in each setting. So the way to do that is to figure out how much wattage is actually consumed in this operation. So if we look at it, wattage equals, and the formula is voltage times amperage. And so we just multiply these two numbers, and we would do the same over here. We'd multiply those two numbers. Wattage equal voltage times amperage. And so I did that, and we looked at this, and it looks like 2.42 watts is what we consumed in terms of our battery over here, moving our motor. And on the output, we got 0.06 watts. So just eyeballing it, you can tell we lost a lot of energy in the translation, in the transition between the two. And in order to figure out efficiency, we just put out over in. And if you put 0.606 over 2.42, you get about a 2% efficiency. So our efficiency for this particular system is not really good. But here again, this motor is probably not particularly efficient in terms of the transmission here. It's got a little bit out around, so we lost some there. We lost some in terms of friction and the efficiency of the motor itself in creating electricity. And so the motor itself loses energy. And then when we go to the generator, here again, we lose some in friction, and we also don't have the most effective generator. This is just a motor, and so we're using it as a generator, so there are probably more efficient motors. So we lose that in that translation. But in this case, about 2%. In a lot of energy transformations, we're lucky if we get 30 or 40% efficiency. So this just shows you how to calculate it, and clearly this is not a very efficient system if we were going to try to generate electricity for any particular or any purposeful use.